Hello, in this video we will talk about ancillary services using renewable sources. Our goal for today is to elaborate on different types of ancillary services and to explain the role of renewable energy resources in their provision. In order to ensure reliable operation, the electricity grids use a multitude of support services, which we call ancillary services. Some of these services existed since the creation of interconnected power systems, while others are a direct consequence of the transformation in our energy supply. Some of these services are provided by the grid operators. Others are provided by large power companies who own and operate power assets in cooperation with the grid operators. Sometimes this cooperation is established through the rules and regulations of the grid codes and is mandatory for all assets of a particular type and size. Sometimes it is established through markets and voluntary participation. The first set of services is related to the support of power system frequency. The frequency is constant when power supply matches power demand and deviates from that value when there are mismatches. The control, maintain, and restore frequency, we can break down the ancillary services into several segments, identifying inertial response reserves, frequency containment reserves, and frequency restoration reserves. We call them reserves since they are reserved to be used when and if they are needed. In this particular case, the provision of frequency restoration reserve is performed through several segments of different size and duration. These type of services can be provided by the renewable energy resources themselves, either if they operate below their maximum power output and or if they are enhanced with energy storage. Both approaches reserve some energy and power to react in response to frequency excursions. Inertial response is interesting since it is a new ancillary service. Historically, it has been provided by the large synchronous generators, which we typically find in fossil fuel plants. At the time, inertia was considered as a technical characteristic of the plants and the system, and there was no need to explicitly define it as a service. Yet, in the renewable-rich power system, without fossil fuel plants and with lower number of synchronous generators in the system, inertia will have to be provided by the renewables. Since the most promising renewable energy sources, wind and solar, do not use synchronous generators, inertial response has to be explicitly defined as a service in order to incentivize its provision. As we already mentioned, the renewables will have to operate below the maximum power output or will have to be enhanced with storage to achieve this control of the frequency. Since additional storage requires a larger initial investment and the operation below maximum power output incurs loss of revenue, the renewables will have to be remunerated for providing these inertial response. And therefore, ancillary service thinking seems rather suitable for this task. The second set of services is related to active power provisioning. The active power services are needed to ensure power balancing. One type of these services are ramping reserves, which are used to match the steep ramps in renewable generation. For example, solar production at sundown. Another type of services are power smoothing services, which ensure that output of renewable sources is smoothed sufficiently before it enters the grid. While ramping reserve services already exist in many power systems, the ancillary services of power smoothing are still to be introduced. Another related services to these is the grid congestion management service, in which we adjust equal amounts of active power of the opposite side on both sides of the congested transmission or distribution line. Energy services, such as peak shaving or valley filling services, as well as secondary and tertiary reserves, are the close relatives of the active power support services. The main characteristic of these services is the supply of a significant share of power over a period of time, or in other words, the supply of energy. Voltage support and reactive power provision are the next set of services. The voltage support is needed at the transmission and at the distribution level of the grid in order to provide suitable operating condition for the transfer of power. By controlling reactive power injection, we can shape the voltage profile across the grid. Note that the voltage support is highly localized service and must be supplied at the location in the grid where it is needed. Similar as with frequency support services, the variable renewables must operate below their maximum active power output and/or must be equipped with energy storage in order to provide these services as well. Grid forming, black start, fault current injection, and harmonic mitigation are the final 4 types of services, each directed at a different need of the grid with high percentage of wind and solar resources. Grid forming services refer to the ability to dictate grid frequency and voltage. Black start services refer to capability of starting up power plants in a grid with no electricity. Fault current injection services are used to overcome challenges with the protection system, which arise as the consequence of replacing conventional sources with renewable sources. Finally, harmonic mitigation services refer to active harmonic filtering by power electronically interfaced sources. In conclusion, we have described in brief a number of ancillary services of interest to the power system. Frequency support, power-related, and other ancillary services are roughly the categories that we group them into. As mentioned, the grid operators have the interest to incorporate these functionalities in the grid operation to improve grid reliability and safety, while the power electronically interfaced sources and storage systems could participate in their provision.